All right, so now let's talk about like the basic process of creating a computer program in the Arduino IDE, or the Integrated Development Environment. The first thing that you need to know is the basic layout of one of these programs. So when you start a new project, so in this case I brought up an example, but when you start a project, you need to realize that there are basically two things that the Arduino is looking for. The first is a routine called setup. This will, I believe, like when you create a new project in Arduino, it'll just come with like this pre-filled out, but blank in between, like where it says setup and the little close brackets. So the setup routine is what is run, the portion of your computer program that is run the second that the Arduino turns on or you press the reset button. If the Arduino turns on or resets itself, it's going to run this once, and so this is usually a good place to do anything that's like a setup routine that just opens like whatever sort of communications protocol you want, or defines like a pin to be high or low permanently, something like that. This is going to set up your base case, and then everything after that is built on top of like the initial condition for your Arduino that's set up here. Then following that, your Arduino is going to start, as soon as it finishes calculating everything that's in your setup routine, it's going to enter the loop routine. The loop routine is basically just run continuously in a loop. That's why it's called that. So basically whatever happens in here, it's going to run through it line by line. When it finishes all of the lines, it's just going to go back to the top, and it's going to keep doing it over and over again. Unlike computer programs on your personal computer, an Arduino program never ends. It just runs in a loop. It's meant to do that. It runs forever until you pull out that power cord. So just recognize that. There are a couple other things that you can do. So that is actually the basic layout of a program. And the program that I have here, if you haven't guessed, is a program to open up your USB serial port. So that's what's done in the setup. And then later, so after it completes setting up your USB, that's your serial communication, then in a loop, it reads your analog pin. So that's analog pin A0 in this case. So the 0th pin gets a value, which is, because it's a digital to analog to digital converter, that value is an integer. The digital number is converted to an integer like that represents the bits, the digital bits, and then that number is printed out in the serial.println command here, and then it delays for 1 millisecond and goes back and does the loop again. So this would run pretty fast. Okay, so a little bit more. So sometimes that's not the only thing you want to do. Sometimes, so you can see that in this particular example, there is a portion up at the top that this is essentially the documentation. So this gray stuff is a comment. You can leave your documentation up there, and that's a good practice. But you can also do some other things in this area. So in class, we'll do an example where we load an external library. So this is like, for example, if you're communicating to some other device other than the Arduino, you may need a library to help set up that communication so that you, as the user, don't have to know everything about what's going on under the hood. So you can load libraries in this location, and I'll show you how to do that. You can also define global variables. So so this is essentially C++. So C++ programming language, every single variable that you use, you have to define what type of variable it is. So is it an integer? Is it like a double precision floating point number? Like, what is it? So you'll see that, like, for example, in front of this sensor value, there's the little letters INT. So that essentially means that when it reads in the analog signal, it's going to cast whatever the digital bits are. So this is going to be a 10-bit signal from an Arduino. It's going to cast that as whatever the integer value associated with those bits are. So it'll be a number between 0 and 120 or 1023, I think. So, but you have to tell it that it's an integer. If the int was not there, it would throw an error when you go to compile. So the next thing to talk about is how to compile. So if you have a working code, let me pull up a laser pointer, you'll take note of these two buttons up here. So the first one with the little check mark is basically for, it's basically the compiler button. So if you press this button, it's going to try to compile this code into an executable binary file that would run on the Arduino. It's not actually going to move it to the Arduino yet, but it is going to compile it and make sure that there aren't any errors. And if there aren't any errors, it will be compiled as a binary. So that's this thing. So if you have a working code, you click this button and it'll just say complete. If you don't have a working code and you click this button, it will give you some sort of error message and try to point you to where in the code it thinks there's a mistake. And you can go and try and fix that mistake. So yay debugging. The second button here, so if I have a compiled binary file, we can move it from your laptop or whatever you're using to do the coding to your Arduino using this button. So this little arrow pushes your binary file from your local computer through the USB cable to the Arduino, and then the second the Arduino receives that file, it's going to reset and start running it the second it receives it. So that's the basic idea.